So now we're back and looking at this final section of chapter 7, 7.4, which gets into problem solving with percent. So it's more of the same type of problems with using P, B, and R, but it's a little bit trickier because of the wording and they're trying to sneak things a little bit in there. So you got to be really careful that you identify them correctly so that way you can get the questions right. But you can always check alternative styles. So if you're not 100% sure, try it more than one way, and one of the answers will stick out as being right, and one of them is going to stick out as being wrong. So I'll show you what I mean. So let's look at this first one. Robert Garrett, who works part-time, earns $210 per week and has 18% of this amount withheld for taxes, Social Security, and Medicare. Find the amount withheld. So one possible thing that we can do, so we kind of know that 18% should be our R. So we can start with that. And now our base and our part are where it can be a little bit trickier. So we got this $210, but we also see over here 18% of this amount withheld for blah, 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 blah. So because this looks like it's unknown, a common mistake would be to say that we don't know what the base is and that the part is $210. Now let's try this out and see what we get. I'm going to use the equation method just because it's a little bit faster. So if we're looking for our base, remember we have to divide our part by our rate. So we would say 210 over 0.18. Well, if we divide that on the calculator, let's see what we get. So we get 1166.666666. So 1166.6, I'll just round it to 7. Now, again, you should match the units. So remember the units are dollars, so this should be dollars as well. But now let's think about this. Does this make sense? So Robert works part-time. He earns $210 per week and has 18% of it withheld for all these different taxes and stuff. Find the amount withheld. So are they withholding $1,166.67 if he's only making $210? That doesn't make sense, right? How can you withhold more than what you're making? That's not a place I want to work. So this can't be right. So what is right? R still is 18%, but the base is 210 and the part is unknown. Now this should give us the right answer. So let's take a look. So if we're looking at for P, we remember we have to multiply these two together. So it'd be 210 times 0.18, which is 37.80. At least I'm pretty sure it is. Let me double check just to make sure. Yeah. So now that makes a little bit more sense. You only have a little bit of it withheld from your paycheck, not more than your paycheck. So this is going to have to be the amount withheld. All right. Let's try the next one. The guided missile destroyer USS Sullivan has a 335-person crew, of which 44 are female. What percent of the crew is female? What percent of the crew is male? Now, again, they throw that word of in there a lot to try to trick you. So they're saying of which 44 are female. So because this follows the word of, is this the base? Well, 335-person crew is not smaller than the 44, so the 44 can't be the base. So that must mean that this is the base. So R is something we don't know. The base is the 335 and the part is the 44. So now we can divide our part by our base, so 44 over 335. Let's see what that is. So 44 divided by 335 equals, looks like we get 0.1313 and change. So 0.1313 and change. And if we change it to a percent, we got to move it 2 places to the right. So we're going to get 13 point, I'm going to use 1 decimal place, 13.1. Okay, so that's half the problem though. We got the percent of the crew that's female. So percent are female. So what about the percent of the crew that's male? Now there's 2 ways that we can tackle this. There's an easy way and then a little bit longer way. So which way do you want to do it? Hopefully you want to do it the easy way, right? Well, think of it like this. This 335 person crew is all of the crew. It's 100% of the crew. We've already allocated 13.1% of that 100%. So how can we quickly get the rest of it from that 100%? The trick is to subtract. If we subtract 13.1% from 100, that's going to give us the leftovers. That's going to be the male constituencies. So 86.9% are male. Now, how else could you have done it? Well, we could go back to the numbers. We know there's a 335 person crew, 44 of them are female. We could subtract those and figure out the actual number that are males. And then we could go through the process and use our PBR again to find the percentage for the men. It's going to be the same result though, so I'm going to skip that work. All right, let's move on to the next one. The Campus Honor Society had hoped to raise $50,000 in donations from businesses for scholarships. It actually raised $69,000. This amount was what percent of the goal? Now you're going to be really careful how you interpret this. Now, a lot of times your gut is saying, oh, the 69,000 is the base because it's smaller than the other number. You know, you want to lean towards having the bigger number as the base, which is not always a bad thing, but in some cases it is, and this is one of them. So now let's try to break apart this statement, this question. This amount was what percent of the goal? So what is this amount referring to? It was referring to the previous sentence, which is the 69,000. So they're saying that 69,000 was what percent of the goal? What did they want to reach for monies? They wanted to reach the 50,000. So 50,000 is following the word of. So 50,000 is the base, which means this has to be the part. So we are looking for the rate. We know the base is 50,000 and we know the part is 69,000. So now we can divide those, which gives us 1.38, which gives us 138%. Now, which seems a little weird because you're over 100%, but again, what we actually reached was more than the goal. It's over 100% of that $50,000. So because you're above 100%, then your percentage is going to be higher than 100%. All right, let's try a few more. Might make this video go a little longer, but we'll see. All right, so Alfonso earned a score of 85 on his test. He did 34 problems correctly. How many problems were on the test? So, what should we do with this one? Well, that 85% is sticking out like a sore thumb. We know that's going to have to be our R. So 85%. So now the question is what's that 34? Is that the base or is that the part? So, well, that's how many he got correct. that wasn't the number of questions on the whole test, because he only got some of those questions right. He got a lot of them. He got 85% of them right, but 34 is what he did right, not what was on the entire test. So that's the part, which means we are looking for the base. Now remember, if you have those backwards, your answer is not going to make sense. So let's see what we get here. So if we divide those, let's see what we get. We get 40. So that's kind of a nice affirmation that we probably got it right. Now, had you had those reversed, we would have had to multiply those two. So let's just see what would happen if we multiplied them. 34 times 0.85 equals 28.9. So you don't even get a whole number from that. So, and then just ask yourself, does 29 questions on the entire test make sense if you got 34 of them right? That's a good trick. So, whoop, I just knocked my camera. All right, let's try this last one and then we'll stop the video. An ad for steel belted radial tires promises 15% better mileage. All right, I like it. If Sheena's SUV has gotten 20.6 miles per gallon in the past, what mileage can she expect after the tires are installed, round to the nearest tenth of a mile? Well, we got a percentage, so that's going to have to be our R. All right, we got this 20.6 miles per gallon in the past. Now this one's a little tricky because there's a couple layers to it. So let's take a look at it both ways and then we'll see which way makes sense. So we got the base and the part. So one thought would be that this might be the part. So let's put it there and see what we get for that. So now the base is equal to the part divided by the percentage. Let's see what that gives us. 137.3. And now again, that's miles per gallon. All right. It's kind of big, but let's see what we get if we switch these two around. So we still got 15%. The base we're going to call 20.6. And so the part we're going to say is unknown. So now the formula says we need to multiply those. So 20.6 times 0.15 equals 3.09, which will round to 3.1. And again, that's miles per gallon. Well, you're probably saying, well, this is a no-brainer. It can't be less. If we're getting better mileage, how can we go down from what we got? It's got to be this one, right? Well, if you can find a tire that's going to give you 137 miles per gallon, then I would buy it in a heartbeat because there's no tire that ever gives that much mileage. So the problem with this is that the question is saying it's getting better mileage, which means you're getting mileage on top of what you're already getting. So this would have to get added to what you're already getting for your new mileage. So this really can't possibly be it. If we add this to this 20.6, that's going to give us the total mileage on the new tires. So the new mileage is going to be the 20.6 plus the 3.1, which is 23.7 miles per gallon. So some of these have an extra little layer in there where you might have to combine stuff together to get your final answer. So just be careful of those ones. But again, you can always double check. One's going to really not make a lot of sense, and this is the one. You can't have that high of a mileage on your tires. There's just no way. So, at least not in our current technology. So, all right, well, let's stop there, and then we'll pick up this last application, which is subtly different than what we've been doing so far. So you'll definitely want to see it. See you in a minute.